In recent times, we have experienced devastating oil spills. This is the oil spill in the Gulf of Mexico, and the oil spill brought about by Typhoon Haiyan. These oil spills are ongoing up until the present. These are destructive in a way that it brings about not only loss of money, but also devastating environmental effects, such as fish kills. There are many ways to clean up oil spills, but scientists have developed a nanomesh that looks like a promising solution to the problem of oil spill cleanups. These scientists, Bhushan, Maharai, and Brown, from Ohio State University, developed a new coating for nanomesh that separates oil and water. As we can see, the red-colored oil stays above the mesh, and the blue-colored water sifts through the net. The creation of this superoleophobic surface is inspired by nature, particularly lotus leaves. As we remember in the previous presentation, we remember how the lotus leaves or self-cleaning surfaces work. The bumpy surface of the lotus leaf repels water. The mesh does the exact opposite of that. It loves water and lets water pass through, but repels oil. The word superoleophobic means very repellent to oil. So what is this nanomesh made of? It is made of four materials, namely stainless steel, silica, polymer, and surfactants. The stainless steel is first bombarded with silica to create a rough, bumpy surface. Then, this is layered off with polymer that is embedded with surfactant molecules. Surfactants can usually be seen in household materials as it makes up dishwashing soap and detergents. This is how surfactants work. The oleophilic tail attract each other and the hydrophilic tail moves away from the water, forming micelles. Surfactants lower the surface tension of oil and water, lowering the energy needed to mix oil into water. In turn, this makes the oil easier to disperse into the water as discrete droplets. Together, these four layers from the materials create a half smooth and half rough surface that performs the opposite function of lotus leaves. Also, gravity plays a big role on the separation process. This paper, entitled Mechanically Durable Superoleophobic Coatings Prepared by Layer Technique for Anti-Smudge and Oil-Water Separation, is one of the two papers produced by Brown and Bhushan regarding their invention. It describes how the nanomesh is produced. This simple technology of separating oil and water has many implications. An immediate use is for oil rigs, used to purify oil from water, as the separated oil is still usable. Another use of this technology are oleophobic surfaces, such as the ones on your touchscreen phones and tablets. The oils from our hands and faces do not seep in and destroy the device. Other probable uses are the filtering of toxic or dangerous household chemicals from drains and sewers, so that untreated waste does not end up in bodies of water or oceans. This is a promising advancement of oil spill cleanups. It has its own merits, being relatively cheap, convenient, and easy to produce. Thank you for listening. I am Dane Ancheta, presenting to you nanomesh that separates oil and water.